everyone. Myself, Dr. M. Prasad Reddy, working as Associate Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. In today's lecture, I am going to discuss source transformation technique. So basically, where you require the source transformation techniques. So in electrical circuits, so if you are going to solve complex circuits and if the circuits having the more number of sources like voltage sources or current sources, so you may need to convert voltage source into the current source or current source into the voltage source for simplification of the electric circuits. So in that particular applications, you may require this particular source transformation technique, and also especially when you are going to study network theorems. So there while you are solving the Thevenin's and Norton's equivalent circuits, so there also you may require the source transformation technique. So while you are expressing the Thevenin's equivalent circuit or Norton's equivalent circuit, so you may require the knowledge of this particular source transformation techniques. So before going to discuss the source transformation techniques, that is how we can convert the voltage source into the current source or current source into the voltage source. First of all, we'll see what are the voltage sources available and what are the current sources are available, how we can represent the voltage source in an electric circuit, if it is an ideal voltage source, how it look like, and if it is a practical voltage source, how it is going to look like. So basically here, the voltage source is used to describe a source of energy, so which establishes a potential difference across its terminal. Suppose if you are taking, this is the electric circuit and here you have the resistor connected. Suppose if you are going to connect one voltage source here, so because of the potential difference between the positive and negative terminal, then the electric current is going to flow through the load resistor R. So that means whenever you connect a voltage source, there will be positive and negative terminals for that particular voltage source. So because of the potential difference between these two terminals, whatever the circuit this particular voltage sources are connected, there will be electric current is going to flow through it. And there are, what are the various types of voltage sources are available? For example, batteries also going to be a voltage source. DC generators, those are going to produce the electric power. So this is also one of the voltage source. Alternators, which are going to generate the voltage. So these are the examples of whatever the voltage sources. And there are two types of voltage sources. So basically, ideal voltage source and practical voltage sources. So what is meant by ideal voltage source or constant voltage source? So in a ideal voltage source, irrespective of whatever the changes in the load, suppose if you can take this particular circuit here, so irrespective of the whatever the changes takes place in the load circuit, whatever the voltage available at the terminal is going to maintain constant. So that means here, whatever the, suppose if you are going to increase the load, obviously if there is an increase in the load, the current drawn by the load also going to increase. So because of the increase in the drawing of load current, there may be changes takes place in the terminal voltage. But if it is an ideal voltage source is connected, whatever the load current drawn by the load, there won't be any change to the terminal voltage. That voltage is maintained as a constant. But if you are taking a practical voltage source, so usually if you are going to take the practical voltage source, whenever you are representing that in a circuit, the voltage source that will be always connected with a small value of resistance, that is called series resistance. So practical voltage sources, always there will be a small value of resistance is connected in series with that particular voltage source. In a practical voltage source, so whatever the changes takes place in the load, there will be a change in the terminal voltage. But in a ideal source, there won't be any change in the terminal voltage because of a small value of resistor series connected in series with the practical voltage source. There will be a small value of voltage drop across this particular resistor. And when you are going to draw the VI characteristics of this particular two cases, so as the load increases here, for the ideal voltage source, this is the terminal voltage, and for a practical voltage source, there will be a small value of drop in the voltage. So this is how we can differentiate between the practical and ideal voltage sources. And the other one, current source. So here, current sources are used to describe a source of energy, so that provides a current to that particular load. So example, collector circuits of transistors. So if you are taking a transistor where you are taking the current, so that is at the collector terminals. And there are two types here. So similar to the voltage sources. So here you have the ideal current source and the practical current source. So what is the ideal current source? So that is irrespective of whatever the changes in the load, the current supplied to the load is going to be same. So in the voltage source, the voltage available at the terminals is going to be same. In case of ideal current source, the current supplied to the load is going to be always same. So here, if you are taking these are the two terminals, so here if you are going to connect some load, whatever the current coming here, that is always constant in case of a practical ideal current sources. But if you are taking a practical current source, always there will be a small value of resistance that is connected in parallel with this particular current source Is. So because of this particular resistance, there will be a small drop in the current supplied to the load whenever there is an increase in the load. And here the characteristics like, so if it is the whatever the current supplied to the load, and in case of the practical cases, there will be a small value of drop in the current supplied to the load. So this is the basic difference between the practical and ideal current sources. So whatever the current sources you are going to deal with in a practical cases, those are going to be the practical current sources. So whenever there is an increase in the load, obviously there will be small changes in the or there will be a decrease in the current. How it is going to happen, we'll see. So here, source transformation techniques. So what you are going to transform here? So if there is any voltage source that is connected in series with a resistance, that you can transform into whatever the current source in parallel with the resistance. So here you can see, so this is the simple voltage source, how we can represent in case of the practical case, and this is whatever the practical current source, how we can represent in a electric circuits. And here you can see this voltage source Vs is connected in series with a small value of resistance Rs. This is the practical case. And also here you can see the current source having the current Is is connected in parallel with the resistance Rs. So that means you can transform from this voltage source to the current source or current source to the voltage source. So if you are converting from voltage source to the current source, how you are going to get what is the value of Is and what is the value of Rs, and if you are going to convert from current source to the voltage source, then what is the value of Vs and what is the value of Rs, that you have to find out. And here you can take a simple circuit having the voltage source V and series resistance Rsc, and here you have the low resistance RL. So as it is a series circuit, the total current flowing through this particular circuit, I am going to take it as the total current I. Then what is the I? So here I equal to V by Rsc plus RL. So that is I equal to voltage by total resistance. That is according to Ohm's law, I can write the total current I equal to V by Rsc plus RL. What is Rsc? That is the small value of resistance connected in series with the voltage source, and RL is going to be the load resistance. And now if you want to replace this particular voltage source by the current source of current I, then what is the current flowing through the load? That current flowing through the load, that should be equal to whatever the current flowing through this particular voltage source circuit. So what is the current flowing through this particular voltage source circuit? That is going to be I equal to V by Rsc plus RL. Then if you are taking the current source circuit, then what is the current flowing through the load here? So that is IL. So what is the IL here? So IL equal to the total current I into opposite resistance, that is RSH by RSH plus RL. So according to current division rule, you can write the expression for whatever the IL, that is IL is going to be total current into RSH by RSH plus RL. So now if you are comparing these two circuits, whatever the voltage source circuit and current source circuit, if you want to convert the voltage source into the current source, the current flowing through the load, that should be same. So now we can equate these two currents, that is what is the I, that is V by Rsc plus RL, that is equal to this particular quantity I into RSH by RSC plus RSH plus RL. So from these two expressions, and also the internal resistance, if you are taking it as the same, suppose if this particular value, what is the RSC? The internal resistance of voltage source, and RSH is internal resistance of current source. And if you are taking these two as equivalent to the R, then from the earlier expression, so you can take V by RSC plus RL, that is equal to I into RSH by RSH plus RL. So as RSH equal to RSC, so the both the denominators are equivalent. So from this you can write V equal to I into RSH. So what is the RSH? You can simply write it as the I into R also. So from this you can write I equal to V by RSE. So what is this particular I? So this particular I. So that means whenever you are converting the voltage source into the current source, then how we are going to represent the circuit? So here the current source is going to parallel with some value of resistance. So what is the value of that current? What is the value of that particular resistance? We have to find. So what is the value of current? So that current I equal to V by RSC. So what is the V? So that is the voltage source. RSC is whatever the internal resistance of that particular voltage source. Now this RSH is going to be RSC, I is going to be V by RSC. In that way you can convert the given voltage source into the current source in a very simple manner. So from this we can conclude that suppose if you are going to convert the voltage source into the current source, then the current source I equal to V by RSC, that is connected in parallel with a equivalent resistance of RSC. So that means here if you are going to convert here, this I is going to be V by RSC and RSH is going to be RSC. And if you are going to convert this particular current source into the voltage source, then this V is going to be I into RSH, this V is going to be I into RSH, then RSC is going to be RSH. So like that you can convert vice versa. You can convert voltage to the current or current to the voltage very easily. You can take a simple example here. So in most of the electric circuits, they may or may not give the electric circuits, but rather than they will give the problem like this: transform a voltage source of 20 volts with internal resistance of 5 ohms to the equivalent current source. First of all, for a given problem, you have to draw the equivalent circuit. And for this particular problem, first of all, you have to draw the equivalent circuit. Here 20 volts voltage source is connected in series with the internal resistance of 5 ohms. So that is 20 volts and 5 ohms both are connected in the series. So this is the given problem and this is going to represent whatever the voltage source. Now we have to convert this particular circuit into the current source. So current source means, so this is going to be I, this is going to be RSC. So what is the value of I? So I equal to V by RSC. What is the V? 20 by 5, that is going to be 4 amps. Then what is this shunt resistance? Is going to be equal to the RSC. So this is simply I am taking the formulas. So what is the value of current? So I equal to V by RSC. Then what is the shunt resistance? RSH equal to RSC, that is the resistance connected in series with the voltage source. So this is the simple way how we can convert the given voltage source into the current source. Similarly, we can take the another example for converting the given current source into the voltage source. So here the problem is transform a current source of 50 amps with the internal resistance of 10 ohms to the equivalent voltage source. So here first of all you have to draw the circuit. So current source means there will be a current source connected in parallel with the resistance. So that means 50 amps is connected in parallel with this particular 10 ohms resistance. So now this is going to be RSH and this is going to be I. So this is going to be I and RSH. Now how we can convert the voltage source? What is the equivalent voltage source? So that means the voltage source is connected in series with the RSC. So this is going to be our voltage source. So what is the value of V? So this is what is the V? V equal to I into RSH. V equal to I into RS. What is the I? That is the 50 amps. What is the RSH? It is the 10 ohms. It is going to be 500 volts. Then what is the RSE series resistance? that is equivalent to the RSH. So that means 500 volts connected in series with the 10 ohms is equivalent to the 50 amps current source connected in parallel with the 10 ohm resistance. So these two circuits are equivalent to each other. So that means whenever you want, whenever you are going to solving some problems related to the electric circuit, wherever you want to convert voltage source to the current source and current source to the voltage source very easily by using these particular formulas. And there are combination of sources, how we can combine the two voltage sources and how we can combine the two current sources. These are the simple ways how we can combine the two voltage sources. So here you can see these two voltage sources of the same polarity are those are connected in the same way. How we can make this, how we can add these two voltage sources means simply it is going to be V1 plus V2. So why? Because both are in the same sign convention. And here you can see, so this also in the same sign convention, but here you can see, so here if you are taking, this is the direction, here it is from negative to positive and here it is from positive to negative. Anyhow, here you have represented it is from positive to negative only. So this is how we can write the equivalent values of given voltage sources. And here you can see again, so these are the two things. I think this is both are same. And here you can see, so this is the another voltage source. So here it is from negative to positive, negative to positive. This is going to be V1 plus V2. And similar way, current sources, how we are going to combine the current sources. As you know, if you are taking a simple series circuit, the same current is flowing through the circuit. So if you are taking the two current sources are connected in series, those two current sources will be having the same value of current. So you can write I1 equal to I2. So in today's class, we have seen what is the voltage source, what is the current source, and how we can transform the given voltage source into the current source or current source into the voltage source. And we have seen a simple example how we can convert the voltage source into the current and current source into the voltage source. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.